Hey there, welcome back to Max World. This is Sachin sir, welcoming you all to part 4 video of surface area and volume. We will be studying Euler's formula. That's the last concept of your lesson today. A great mathematician, Leonhard Euler, established a formula F plus V equals to E plus 2. He studied lot about polyhedrons. In this formula, F stands for number of faces, V stands for number of vertices, and E stands for number of edges that a solid figure has. In this lesson, we will be getting a question based on verification of Euler's formula, or 3 of these F, V and E, any 2 will be given and you need to find the remaining one. Before proceeding further, let's observe this video and try to learn how to find faces, vertices and edges just by name of the solid. Girls, let's try to understand something more about quadrangular prism. It is not new for you. The dice you use while playing Ludo, you say, or snake and ladder is nothing but the example of your this quadrangular prism. All these 3 shapes are quadrangular prism. These 2 are cube and this one is cuboid over here. How to identify them? If you observe this cube, you will come to know that it has 6 faces, 1 at the bottom, 1 at the top and 4 standing, 1, 2, 3 and then 4 over here. All these 6 faces are squares, and for the cuboid, at the bottom, at the top, on a standing portion, you will come to know that it is made up of rectangles. So in short, cubes are made up of 6 square faces and cuboid is made up of 6 rectangular faces. Now let's try to count the vertices in these diagrams or in these shapes. For all these 3, the bottom is quadrangle, means there are 4 vertices, 1, 2, 3, 4. My dear, vertices are the vertex for the quadrangle, nothing but the point where 2 sides meet each other is called as a vertex. So over here, this one side meeting each other over here, so this corner is called as a vertex. So in that manner, we have 1, 2, 3, 4 vertex down and 4 vertices at the top. So 4 vertices down, 4 vertices at the top. So we have in short 8 vertices. Same goes over here with the cuboid. We have 1, 2, 3, 4 corners or 4 vertices at the bottom, and at the top again we have 4. 1, 2, 3, 4. So we have 8 vertices for this cuboid also. So for the cube and the cuboid, they have 6 faces, 8 vertices, and now let's try to count the edges. Edges means these lines over here, straight lines, standing lines, or over here slipping lines. Okay. Now let's try to count them. At the bottom we have 1, 2, 3, 4. At the top again 1, 2, 3, 4 and 4 standing. So in short, 4 at the bottom, 4 at the top and 4 in a standing position. So in short, we have 12 edges for the cube. Same goes with the cuboid. At the bottom we have 4 edges. At the top we have 4 edges, and in the standing position again we have 4 edges. So in short, we have 12 edges for the cuboid also. This pentagonal pyramid, boys and girls, now very first keep it in mind, if it is pyramid, okay, if it is pyramid, then at the top we do not consider any face because point is there. Okay, very first. Next thing, as it is pentagon, so 5 standing faces will be there for the pentagon. Penta means 5, hexa means 6, hepta means 7, octa means 8. Keep it in mind. I repeat again. Quadrilateral means 4 sides. Pentagonal means 5 sides. Diagram with 5 sides. Hexa stands for 6. Hepta stands for 7. Octa stands for 8. Okay. So over here it is pentagonal pyramid. So pentagonal pyramid means what? From these 5 sides we will have 5 standing faces and 1 face at the bottom. So 5 standing, 1 at the bottom. So we have in short 6 faces, right? Now think about the vertices. We have 5, it's a pentagonal, right? So 5 point will be there, or the 5 vertices will be there at the bottom. 1, 2, 3, 4, 5, and 5 are down and 1 is at the top. So in short, we have 6 faces, 1 at the bottom and 5 standing. 6 faces, again 6 vertices, 5 at the bottom and 1 at the top. So in short, faces and vertices for the pyramid will always remain same. Keep it in mind. What's I said? Faces and the vertices for the pyramid will always remain same. Okay, so we have 6 faces for the pentagonal pyramid, 6 vertices, and now let's think about the edges. See, edges means what? That corners, okay, that sides. So we have 5 sides at the bottom, right? From these 5 sides, or these 5 points, again 5 sides will move up, right? See here, 1, 2, then this 3, then this 4, and this 5. So 5 sides at the bottom, 5 sides moving towards point or the tip. So we have 10 sides in all, right? 10 edges in all. So for this pentagonal pyramid, what we have? 6 faces, 6 vertices, and 10 edges. Okay, now boys and girls, let's try to find out faces, vertices and the edges for hexagonal pyramid. Now let's try to calculate or estimate it just by observing the name of it. It's a hexagonal pyramid. It's a hexagonal means what? At the bottom we have 1 face, and as there are 6 sides, hexagonal means what? Hexa means what? 6, right? So as there are 6 sides at the bottom, so what will happen? 6 faces will move upward towards the apex or towards the tip. Okay, so 6 faces are moving upward and 1 face is at the bottom. So in short, we have 7 faces for this hexagonal pyramid. Okay, isn't it right? Check out now. For hexagonal, the 1 is at the base, and from every side, 1, 2, 3, 4, 5 and 6. From every side, one face moved up. That means 6 sides are there, so 6 faces moved up and 1 face is at the bottom. So there are 7 faces, right? Now let's think about the vertices. As there is a hexagon at the bottom, so we have 6 point. Hexa means 6. So 6 points are there at the bottom and 1 point is at the top. So in short, we have again 7 vertices. So in short, we have 7 faces and 7 vertices. Now let's think about the edges. Again, it's a hexagon, so 6 edges are already there at the bottom, and from every vertex a straight line is moving upward. So these are also 6 lines, right? 1, I'm cutting from this thumb. 1, 2, 3, 4, 5, 6. So 6 edges moving upward, 6 edges at the bottom. So in short, we have 12 edges for hexagonal pyramid. So as a summary, we have 7 faces, 7 vertices and the 12 edges for this hexagonal pyramid. Now let's think about the prism. This is hexagonal prism. Okay, so let's think about the faces. We have 1 face at the top, 1 face at the bottom. It's a hexagonal, so from 6 sides, 6 faces will move up, right? As there are 6 sides, hexa means 6 sides are there. From every side, 1 face will move up. The way you are looking in this diagram or in this shape, this is a hexagon, this is 1 side, so 1 face moved up. Second side, so second face moved up. So in short, 6 faces will move up. 1 face at the top, another face at the bottom. So we have 8 faces in short for this prism, right? Now let's think about the vertices. There is a hexagon at the top, there is a hexagon at the bottom. So 6 point or the 6 vertices at the top, 6 vertices at the bottom. 6 plus 6, there are 12 vertices for this hexagonal prism. So we have 8 faces, 12 vertices, and now let's think about the edges for this hexagonal prism. Again, it's very easy. 6 corners or the 6 edges at the bottom, 6 edges at the top, and from point to point again 1 edge is moving, right? So in short, 6 edges moving upward. 6 above, 6 at the bottom, 6 moving upward. So 6 3s are 18. So 18 edges will be there in this diagram. So in short, we have 8 faces, 12 vertices and 18 edges for this prism. Okay. Now let's think about this next one, pentagonal prism. Now boys and girls, without looking at this, we will try to understand it. Pentagonal prism, it is a prism, so we have one face at the bottom, one face at the top. As it is pentagon, means 5 sides are there. So as 5 sides are there, so 5 faces will move up. So 5 faces are going up, one is at the top, one is at the bottom. So there are 7 in short faces for the pentagonal prism. Isn't it right? Just count down. One at the bottom, one at the top, and from each side, as there are 5 sides, 1, 2, 3, 4, 5 sides, each side is moving upward, creating one face, right? So 5 sides will have 5 faces, one is at the top, one is at the bottom. In short, there are 7 faces. Now let's think about the vertices. This is the prism, means at the top flat portion is there, at the bottom flat portion is there. It's a pentagon, so 5 points will be there up, 5 points will be there at the bottom. So 5 plus 5, 10. So 10 vertices there will be there for this diagram. And now for the edges, same thing will go will move up, like 5 edges up, because it's a pentagon. 5 edges will be at the bottom, and from vertex to vertex, one edge will move up, right? So 5 edges are moving up. So in short, we have 5 edges at the top, 5 edges at the bottom, 5 are moving up. So 5 is a 15. So in short, we have 15 edges for this pentagonal prism. I hope I'm making it very clear to you all. So in short, we have 7 faces, 10 vertices and 15 edges for pentagonal prism. Boys and girls, try to be with the habit that just by listening to the name, you will be able to make out how many faces, vertices and the edges are there. So students, I hope you've understood how to find the F, V and E, that is faces, vertices and edges. For the cube, it has 6 faces, 8 vertices and 12 edges. Same goes with the cuboid, because they are one and the same type of prism, that is quadrilateral prism. For pentagonal pyramid, we have 6 faces, 6 vertices and 10 edges. Now for these 3 questions, okay, 3 solid figures, we will try to verify the Euler's formula. Now how to verify the Euler's formula? It has 2 sides. On LHS, it has F plus V, that is faces plus vertices, and on right hand side it has E plus 2, that is edges plus 2. If I add F and V, whatever the answer I get, that same answer should be there when you add 2 to edges. Okay, the moment we add 6 and 8 of cube, we get the answer 14, and when you add 2 to edges, that is 12 plus 2, we get the answer 14. Now we got both the answers same, 14 on LHS, 14 on RHS. So we can say Euler's formula is verified for the cube. For cuboid also same thing will happen. Now let's focus on pentagonal pyramid. It has 6 faces and 6 vertices. Add them, we get the answer 12. Now for the edges, we need to add 2. 10 is already there, so 10 plus 2 again 12. So on both the side we get same value, that is 12 and 12. That is why again for pentagonal pyramid the verification is done. Now let's try to find one of the value of F, V and E if remaining 2 are given to us. Okay, for the hexagonal pyramid, now faces and vertices are given, that is 7, 7, and I need to find the edges. Okay, now this is for sure, whatever the value I get after adding F and V, the same answer should come when you add 2 to edges. Okay, 7 plus 7 I get the answer 14. Now the 2 along with the edges must be subtracted from this 14 to get the answer of E. So 14 minus 2, answer will be 12, and that is why the value of edges for the hexagonal pyramid is 12. Once you get the answer, you can again verify the Euler's formula. 7 plus 7 14 and edges plus 2, that is 12 plus 2, answer again it comes 40. So the formula is verified. For hexagonal pyramid, vertices and edges are given. Now I will try to find the faces. As faces I need to find, so f plus v cannot be done. I will be focusing on right hand side, that is e plus 2. Now for 18 I will add 2 to it, we get the answer 20. Now if I subtract 12 from, that is vertices number, from 20, I must get the answer for the faces, and that answer is 8. Isn't it right? Of course. Oh, I hope you understood how to find the remaining term. Let's try to find the details for pentagonal prism. Now again, vertices and edges are given. F plus v cannot be done because f I need to find. What is the right hand side? E plus 2. The value of e is given to me, that is 15. So add 2 to it, we get the answer 17. From that 17, I need to subtract 10 to get the answer of faces. The moment to subtract, I get the answer 7, and that's what is the final answer for pentagonal prism. I hope you understood. Now boys and girls, it is your time to try your knowledge. These are some 3D shapes along with their details given to you, and the missing detail you need to find by using Euler's formula. Do not forget to mention the answer in the comment section below. I'll be waiting for it. See you soon.